Students, let us continue the next problem on the principle of mathematical induction in the exercise. Here, 13th problem of the exercise 4.1, 1 plus 3 by 1 into 1 plus 5 by 4 into 1 plus 7 by 9, so on up to n terms, 1 plus 2n plus 1 divided by n square. This is a LHS part is equal to n plus 1 whole square is that. Here actually in a previous problems we used to see that plus in between, but here product of the terms is that one bracket, this is the first bracket, first term, second term, third term, product of the terms is that has like a geometric progression. You know, here this LHS is equal to RHS we need to prove by the principle of mathematical induction. As you people know that principle of mathematical induction. What is the principle of mathematical induction? There are particularly the three steps. What is the first step? Step 1, basic step. That is, we should say that for n equal to 1, whether LHS is equal to the RHS. Second step, assumption step. We need to assume that P of k is true. Third step is we need to prove that P of k plus 1 is true whenever P of k is true. So now let's begin the solution. Step number 1. I just call this as the P of n. Consider this as a P of n. Now step number 1. What is the step number 1? Basic step. In the basic step, for n is equal to 1, whether LHS is equal to the RHS is there or not, check LHS value. For n equal to 1 is when equal to first term. What is the first term of the LHS? 1 plus 3 divided by 1. This is the first term. Second term, third term, like that. This is the nth term. Simplify. 1, 3 by 1 is 3. 3 plus 1 is 4. LHS value is 4. Similarly, the RHS value. RHS, wherever it is there, replace the 1. 1 plus 1, 2. Whole square. That is the 4. Whether LHS is equal to the RHS? Yes. LHS is equal to the RHS. Therefore, we can say that P of 1 is true. Therefore, we can say that P of 1 is true. Next, step number 2. What is the step number 2? Assumption step. Assume that P of k is true. Assume that P of k is true. So what will you get the P of k? Wherever n is there, replace the k. First term, 1 plus 3 divided by 1, 1 plus 5 by 4, 1 plus 7 by 9. So on. Last term, 1 plus in place of n, k. 2k plus 1 divided by k square is equal to k plus 1 whole square. Call this as a equation number 1. Now, so we need to prove that. Next up, we have already assumed that this is a true for n equal to k. Next, we need to prove that third step. What is that? We need to prove that P of k plus 1 is true. P of k plus 1 is true whenever P of k is true. Whenever P of k is true. So what is the P of k plus 1? First of all, write the P of k plus 1. In place of n, replace the k plus 1. So first term as it is 1 plus 3 by 1 into 1 plus 5 by 4 into 1 plus 7 by 9. So on. 1 plus in place of n, k plus 1. That what we get in place of n, k plus 1. 2 into n plus 1. Okay. 2k plus 2 plus 3. That is 2k plus 3. This thing divided by k plus 1 whole square. Okay. What is the previous term? Previous term is product is that. Product in terms of k. That is 1 plus 2k plus 1 divided by k square is equal to right hand side. Wherever n is there, replace the k plus 1. K plus 1 plus 1. That is nothing but k plus 2. Whole square. Now we need to prove that LHS is equal to the RHS. So that consider the LHS value. What is the LHS value? 1 plus 3 by 1 into 1 plus 5 by 4 into sort 1 plus 2k plus 1 divided by k square into 1 plus 2k plus 3 divided by k plus 1 whole square. Okay. Here instead of the plus, product is there. Nothing to worry. What we can replace these terms. First k terms. First k terms value from the equation number 1. What is that? 1 plus 3 by 1 into 1 plus 5 by 4 plus what? 1 plus 2k plus 1 divided by k square value is how much? K plus 1 whole square. K plus 1 whole square into remaining term. What is the remaining term? 1 plus 2k plus 3 divided by k plus 1 whole square. This is the value. Now after simplification we have to get the k plus 2 whole square. Okay, let us simplify. This outside k plus 1 whole square is that. In this bracket take LCM as a k plus 1 whole square. Here k plus 1 whole square is that. I just use the flower bracket. Here k plus 1 whole square is the LCM. Here k plus 1 whole square plus 2k plus 3. 2k plus 3. Here I just use the block. Okay. Now I just simplify here. So observe that k plus 1 whole square outside k plus 1 whole square is there. In the flower bucket denominator k plus 1 whole square is there. You can keep outside, no, nothing to worry. Flower bucket. What is left in the flower bucket? K plus 1 whole square plus 2k plus 3 is left. 2k plus 3 is there. Okay, are you sure? K plus 1 as it is. This k plus 1 whole square outside. So this k plus 1 whole square, k plus 1 whole square get cancelled. Remaining term k plus 1 whole square is that. A plus b whole square. That is nothing but k square plus 1 plus 2k plus 2k plus 3 as it is. Simplify. K square 2k plus 2k, that is 4k. 1 plus 3 is 4. Now it is the perfect square. So can I add this as a k plus 2 whole square? Expanded k plus 2 whole square by using the a plus b whole square formula. Will you get this one? Yes, exactly. So hence we just get the RHS. LHS is equal to the RHS. Therefore we got the result P of k plus 1 is 2. P of k plus 1 is 2 whenever P of k is 2. Whenever P of k is 2. So finally the conclusion. What is the conclusion? By the principle of mathematical induction. By the principle of mathematical induction, P of n is 2. P of n is 2 for all n belong to the natural number. For all n belong to the natural number, or else you can say that n belong to the positive integers. That's the solution. Okay, very simple problems. Now move to the next one. 1 square plus 3 square plus 5 square plus sum plus 2n minus 1 whole square is equal to n into 2n minus 1 into 2n plus 1 divided by 3. What is the meaning of this one? This is the meaning of sum of squares of first n odd integers. Sum of squares of first odd integer. Already know that the sum of squares of first n integer, sum of cubes of first n integer, sum of the first n integer. Here also sum of squares of first n odd integer. What are the odd integer? 1, 3, 5, 7, 9, 11. These are all the odd number. So for these odd number, nth term is the 2n minus 1, provided that n is the any positive integer. Is that clear? So we need to prove that LHS is equal to RHS. So first of all, I just consider this is the P of n. I hope you can easily proceed this one. The problem is in the third step. Okay, no problem. We have a hint. What is that hint to solve in the third step? First one, replacement. Next, LCM. Next, common and simplify. That's all. Okay, I just consider this is the P of n. Step number 1. What is the step number 1? For n is equal to 1. Whether LHS is equal to the RHS second. LHS value. What is the LHS value? First term of the LHS. What is the first term of the LHS? 1 square. Or else we just replace n value only in the nth term. Is that the answer? 1 square value is 1. Similarly, RHS value. In the RHS, wherever n is there, replace 1. N value is 1 into. N value is 1. 2 minus 1 is 1. 2 plus 1 is 3. Divided by 3. 3 gives answer is equal to 1. 1, 1. LHS is equal to the RHS. Therefore, P of 1 is 2. Therefore, P of 1 is true. Next, step number 2. What is the step number 2? Assumption step. Assume that P of K is true. Assume that P of K is true. But P of K, write the P of K. Wherever n is there, replace the K. What happens? 1 square plus 3 square plus 5 square plus 1 plus 2k minus 1 whole square is equal to k into 2k minus 1 into 2k plus 1 whole thing divided by 3. Call this as equation number 1. Now, we have assumed that the given statement is true for n equal to k. Now, move to the step number 3. What is the step number 3? We need to prove that P of k plus 1 is true. We need to prove that P of k plus 1 is true. We need to prove that P of k plus 1 is true. Whenever P of k is true. Whenever P of k is true. At P of k plus 1. What is the P of k plus 1? In place of n, replace the k plus 1. 1 square plus 3 square plus 5 square plus so on plus in place of n, k plus 1. 2 into k plus 1 minus 1 is 2k plus 2 minus 1 plus 1. That means 2k plus 1. That whole square as it is. What is the previous term of this one? Previous term is as it is in terms of k. 2k minus 1 whole square. Okay, right answer. Wherever n is there, replace the k plus 1. This is k plus 1. 2n minus 1 in place of n, k plus 1. What we get? 2k plus 1. And this comes 2k plus 3. You can calculate whole thing divided by 3. So now we need to simplify this one. LHS is equal to RHS is required to get. So consider the LHS value. What is the LHS value? 1 square plus 3 square plus 5 square plus so on 2k minus 1 whole square plus 2k plus 1 whole square. We need to do LHS is equal to RHS. So while doing LHS is equal to RHS, what is the first thing? We have to replace it. What we have to replace? Equation number 1. What is equation number 1? 1 square plus 3 square plus 5 square plus so on 2k minus 1 whole square is replaced as k into 2k minus 1 into 2k plus 1 whole thing divided by 3 and the plus 2k plus 1 whole square term absence. Now, after replacement, then take the LCM. What is the LCM? 3 is the LCM. I just write the 1 by 3 LCM. 3 is LCM or 1 by 3 is common. What happens? K into 2k minus 1 into 2k plus 1 plus 1 by 3 is common. Here we need to multiply the 3 into 2k plus 1 whole square. Okay. Now, after taking the LCM, now take the common. Is anything common? Check it. I just continue here. Is anything common here in the block? Okay. Observe. 2k plus 1, 2k plus 1 whole square is there. 2k plus 1 is common. 2k plus 1 is common. Whole thing divided by 3 as it is. Remaining term k is left. 2k minus 1 is left and plus 3 into 2k plus 1 whole square is that 1 2k plus 1 is outside, remaining 2k plus 1. Now after taking the common, simplify to get the required term. What we need to get? K plus 1, 2k plus 1, 2k plus 3 divided by 3. Already we just have the 3 and 2k plus 1. We need to get the k plus 1 and 2k plus 3. So k is anything common? Nothing is common. So open the bracket and simplify. Factorize the quadratic equation, will get it. Okay. Multiply 2k square minus k plus 6k plus 3. Okay. 2k plus 1 divided by 3. 2k square as it is minus k plus 6k is plus 5k plus 3. Okay. Multiplying or dividing, we should get the 3. 2 3s are 6. Adding or subtracting, we should get the 5. How do you split? That is 2k square plus 2k plus 3k plus 3. Grouping the terms. 2k plus 1 divided by 3 as it is. Here from the first two term 2k is common. What is that? K plus 1 is left. Next two term plus 3 is common. K plus 1 is left. K plus 1 is common. Already 2k plus 1 is outside. K plus 1 is outside. Remaining term 2k plus 3. I got the required term. What is the required term? K plus 1. Do you have that? Yes. K plus 1 is the 2k plus 1. Yes. 2k plus 1. Yes. Next 2k plus 3. 2k plus 3. Whole thing divided by 3. Whole thing divided by 3. Hence the required RHS. Therefore, finally conclusion. Therefore, P of k plus 1 is true. P of k plus 1 is true whenever P of k is true. Then finally write the conclusion. What is the conclusion? Conclusion. By the principle of mathematical induction, P of n is true. P of n is true for all n belong to the natural number or n belong to the positive integer. Hence the solution. So here you may get the we may face the problem by simplifying the third step. So for simplifying the third step, this is follow these 4 steps. We will get the required answer very easily. There is no confusion at all. Okay. Now let's go to the next. The next one is 1 by 3 into 5 plus 1 by 5 into 7 plus 1 by 7 into 9 plus sum. 1 divided by 2n plus 1 into 2n plus 3. First term 3, 5, 7. That is nth term is 2n plus 1. Second term 5, 7, 9. That nth term is 2n plus 3. This sum is equal to how much? N divided by 3 into 2n plus 3. That we need to prove by the help of the principle of mathematical induction. Pause the video, you just solve it and cross it. Okay. Step number 1. I just consider first of all this is the P of n. So step number 1. For n equal to 1, whether LHS is equal to the RHS is there or not? Check it. Okay, LHS value. What is the first term? 1 divided by 3 into 5. 1 divided by 3 into 5. 3 into 5. 50. So 1 divided by 50. LHS value is 1 by 50. Similarly, go for the RHS. RHS, wherever n is there, replace 1. 1 divided by 3 into 2 plus 3. 2 plus 3 is 5. 5 3s are 50. So 1 divided by 50. LHS is equal to RHS. Therefore, P of 1 is true. Now, step number 2. What is the step number 2? We assume that P of k is true. Assume that P of k is true. So what happens? P of k is true. So P of k is true means P of k. What is the P of k? 1 divided by 3 into 5 plus 1 divided by 5 into 7 plus 1 divided by 7 into 9 plus so on plus 1 divided by 2k plus 1 into 2k plus 3 is equal to, in place of n, replace the k divided by 3 into 2k plus 3. Call this as equation number 1. Now, go to the third step. What is the third step? Let's see now. Yes. Go to the step number 3. What is the step number 3? We need to prove that P of k plus 1 is true. We need to prove that P of k plus 1 is true. Whenever P of k is true, just write it. Next, I just write the P of k plus 1 statement. What is the P of k plus 1? P of k plus 1 is, wherever k n is there, replace the k plus 1. So 1 divided by 3 into 5 plus 1 divided by 5 into 7 plus 7 plus. Here only n terms are there. Then after replacing, in place of n k plus 1, that will becomes a k plus 1 terms. So here in place of n k plus 1, 2 into k plus 1 plus 1, that we can write 2k, 2 plus 1 3, 2k plus 3 into 2k plus 5. This is the k plus 1 term. What is the previous term? Previous term is same, in place of n k, 2k plus 1 into 2k plus 3. What is the finally right hand side? As is right below here, in place of n k plus 1 divided by 3 into 2k, 2 into k plus 1 plus 2 plus 3 is plus 5. Okay. Now we need to prove that LHS is equal to the RHS. So consider the LHS value. Okay, I just write directly, replace it. Okay, LHS value. What we can replace these values? This value can be replaced from the equation number 1. What is that? K divided by 3 into 2k plus 3. K divided by 3 into 2k plus 3 from the equation number 1. Remaining term, this is the remaining term, write it, plus 1 divided by 2k plus 3 into 2k plus 5. Okay, after replacing, what we have to do? We have to take the LCM, or else take it as a common. First of all, I just take the common. Is anything common? Yes. 1 by 2k plus 3, 1 by 2k plus 3 is common. So 1 by 2k plus 3 is taken common. What is left? K is left, divided by 3 is left, 1 divided by 2k plus 5 is left. Okay. Now, take up LCM. So I have already mentioned that there replacement, after the replacement, we can take a LCM or a common. That two things might be interchanged. Anyway, after taking the LCM, common, let's take the LCM. 1 divided by 2k plus 3 as it is. Into. Take LCM. What is LCM? 3 into 2k plus 5. In the plural bracket. 3 into 2k plus 5 is the LCM. K into, here 3 is the multiplied by 2k plus 5. Plus 1 is the multiplied by 3. Okay. Now, simplify. 1 divided by 2k plus 3 into 1 divided by 3 into 2k plus 5. Numerator 12. What we can write? Open the bracket. 2k square plus 5k plus 3. What we need exactly? Numerator k plus 1, denominator 3 into 2k plus 5. 3 into 2k plus 5 already is there. We have to eliminate the 2k plus 3. How to eliminate? So quadratic equation, write in the factorized form. 3 into 2k plus 3 into 2k plus 5. Okay. 2k square plus 5k is there. Okay. Multiplying or dividing, we should get the 6. Adding or subtracting, we should get the 5. 2k square plus 2k plus 3k plus 3. Okay. So 2k is common. K plus 1 is left from the first two terms. From the next two terms, plus 3 is common. K plus 1 is left. Whole thing divided by 3 into 2k plus 3 into 2k plus 5. Okay. So whole thing divided by 3 into 2k plus 3 into 2k plus 5 is left. Numerator k plus 1 is common from these two terms. Remaining term 2k plus 3. So numerator also 2k plus 3. Denominator also 2k plus 3. Get cancelled. What is remaining term in the numerator? K plus 1 is left divided by 3 is left. 2k plus 5 is left. Check it. I got the required RHS. K plus 1 divided by 3 into 2k plus 5 is the required RHS. So therefore P of k plus 1 is 2. Then finally the conclusion. What is the conclusion? By the principle of mathematical induction, P of n is true for all the natural number. Hence the solution. This is all the very important type of the problem. Now, in the same PMI, principle of mathematical induction, let's take the different type of the problem. Different type of the problem is while solving or getting that LHS equal to RHS, here we need to substitute. You are substituting equation number 1 directly. Instead of substituting equation number 1 directly, the different substitution is that. Let's have a look on that type of the problem. Okay. Here, instead of giving the statement or mathematical formulation LHS is equal to RHS, they are given a words. What is the given thing? Let's have a look. Example 6 solved problem in the NCERT book. Prove that 2 into 7 power n plus 3 into 5 power n minus 5. This number, what is that number? 2 into 7 power n plus 3 into 5 power n minus 5 is divisible by 24 for all the natural number. Prove that by the principle of mathematical induction, this quantity is divisible by 24 for all the natural number. How to decide that? Suppose if I replace the n value as 1, natural number, what are the natural number? 1, 2, 3, 4 like that. It continues. Okay. If I replace the n equal to 1, what happens? 7 power 1, 7. 2 into 7, 14. 5 power 1, 5. 3 into 5, 15 minus 5. So here 15 minus 5, 10. 10 plus 14, 24. 24 is divisible by 24 like that. If I replace the n is equal to 2, what will get? Check it. 7 square, 7 square. 7 square is 49. 49 2s are, that is 98 plus 5 square 25. 25 3s are 75 minus 5. 98 plus 75 1 98, that is 98 plus 70. 98 plus 70, what we get? That is 168. 168. 168 is divisible by 24. Yes, obviously it is divisible by 24. Yes, in that manner we have to continue. N is equal to 3, n is equal to 4. It is in the same manner. It is true for n is whatever the natural number. We have to, by the help of the principle of mathematical induction, let's prove it. So first of all, I need to get the mathematical statement to apply the PMI. What is the mathematical statement? That is nothing but the P of n. What is the P of n? The expression 2 into 7 power n plus 3 into 5 power n minus 5 is divisible by 24. Is divisible by 24 is nothing but can write as a 24 times of some p. 24 times of some p. What is a p? P is a multiple. 24 how much are this much? 24 how much are this much? That's why I just written a p. What is a p? P is a unique integer. P is a particularly integer, that is particularly a positive integer. Now have you got the mathematical statement? LHS is equal to RHS. Okay, so this is the P of n. Now let's start that by using the principle of mathematical induction. Prove it is. Step number 1, for n equal to 1. For n equal to 1, in this case, LHS is equal to RHS will not get. What will get? LHS value for n equal to 1. What is that? 2 into 7. 2 into 7 power 1 is 7 plus 3 into 5 minus 5. Already it is written. 14 plus 15 minus 5 is equal to 24. Now further check the statement is true or not. This number for n equal to 1 is 24 is divisible by 24. Yes, 24 is divisible by 24. Can I write that P of 1 is 2? Yes, obviously the P of 1 is 2. I got it. This is the another type of the problem. They are not given mathematically equation in this manner. They are given a statement. That statement we have to convert in this manner. Okay. So just take that 24 times of. Other than the n, remaining 25 letters are there to consider. Is that clear? Some people used to write that 24 times of n, which will be wrong because here also n, here also n. That is not a suitable thing. This n is different, this number is different. Is clear? So apart from the n, remaining 25 letters are there. Let's choose any one of the letter. So I just choose a P. As your wish, whatever. Okay. Now first step is true. Now come for the second step. What is the second step? Step number 2. Assumption step. Assume that P of k is true. Assume that P of k is true. What will get the P of k? P of k is equal to 2 into wherever n is there, replace the k. 2 into 7 power k plus 3 into 5 power k minus 5 is equal to 24 times of. Here, don't call this as equation number 1. In this type of expression or statement they have given in the principle of mathematical induction, do that get the first term value is equal to, what is the first term? 2 into 7 power k is that is equal to how much? Shift this all terms into right hand side. 24 times of p minus 3 into 5 power k plus 5. Now all this is the equation number 1. Remember the hint. What is the hint? Whenever they are given this type of equation or statement, in that case, first term value. What is the first term value? 2 into 7 power n. Here I am writing in place of n as a k. So first term value 2 into 7 power k is equal to how much? Whatever. Suppose it is 3 into 5 power n were the first term. Then add the 3 into 5 power k is equal to. Whatever the first term is there, right, first term is equal. Okay, remaining all the term shifting into right hand side. Now, this is equation number 1. Next one. Why I am just writing this one? We will come knowing in the third step. Okay, step number 3. What is the step number 3? We need to do that. We need to do that. P of k plus 1 is true. We need to prove that P of k plus 1 is true whenever P of k is true. This is my thing. Now I just write the P of k plus 1. What is the P of k plus 1? Wherever it is there, replace the k plus 1. Here 2 into 7 power k plus 1 plus 3 into 5 power k plus 1 minus 5 is equal to 24 times of p. Okay. Now we need to prove that LHS is equal to RHS, which is nothing but in this case we have to tell that this LHS part is divisible by 24. We have to conclude that LHS part is divisible by 24. How do you conclude that? So consider the LHS. LHS is equal to 2 into 7 power k plus 1 plus 3 into 5 power k plus 1 minus 5. We have to say that this number is divisible by 24. This number is divisible by 24, which is nothing but it is sufficient to take the 24 is common from all these terms. I got my point? We are required to say that this is divisible by 24. Okay. So it is sufficient to take the 24 is common. 24 should be common from the first term, 24 should be common from the second term, 24 is common from the third term. So from all the three terms, we have to take the 24 is common. Then we can easily say that it is divisible by 24. Is it directly true? Here unknown value k is there, which is not possible. So that reason. So usually in a previous type of the problem, we used to replace the first k terms value, which is not possible to replace here. Is that clear? So that what I just need to write as a split the term. How I just split the term is nothing but by the help of the laws of induction. 2 into 7 power k plus 1 is that. 7 power k plus 1 can I write as 2 into 7 power k. Basis are same, add indices. 7 power 1 into 7 power k will equal to 7 power k plus 1. Yes. Next, similarly, 3 into 5 power k plus 1 can be written as 5 into 5 power k minus 1. Okay. After rewriting, after splitting this one, this type of product, whatever the problem they are given in this manner, some number divisible by some another number they given, we have to follow in this manner. Shortcut in this case. Okay. Now we have the value. What is the value from the equation number 1? 2 into 7 power k is that. Replace that 2 into 7 power k. I just rewrite 7. 2 into 7 power k plus 3 pies are 15. How it 15 becomes 3 into 5. 3 pies are 15. 5 power k minus 1. Now I am just replacing the 2 into 7 power k from the equation number 1. What is the 2 into 7 power k? This is the value. Replace it. What will get? 7 as it is. 2 into 7 power k value is 24 times of p minus 3 into 5 power k. 3 into 5 power k plus 5 plus 5. This is the 2 7 power k value is over plus remaining value. What is the remaining value? Plus 15 into 5 power k. 15 into 5 power k minus 5. Now simplify this one. After simplification, what we have to get? We have to get the 24 is common. If you got the 24 is common, then this number is divisible by 24. Okay. So here our aim is to get the 24 is common. Okay. So I already need to take the 24 is common. So that write as it is. 24 into 7. Don't multiply. Keep as it is. 24p into 7 can be written as in this manner. Minus 3 into 7. 21 into 5 power k plus 5 into 7. 35 plus 15 times of 5 over k minus 5. For these two terms, 7 is not difference. I got this one. How do you get this one? 7 into this cloud bucket. I have not multiplied 24 7. I have not written 24 7 because I need to take the 24 is common. I just kept as it is 24. 7 into p, 7 into 3, 21. 5 over k as it is. Next, 7 into 5, 35 plus 15 into 5 power k minus 5 as it is. This term which is not possible to simplify, keep as it is. Now, like terms. Is any like terms are there? 24 into 7p, 5 power k, 5 power k with the coefficient minus 21 and plus 15 is there. What will get here? So minus 21 times of 5 power k plus 15 times of 5 power k. Check the sign whether it is a positive or negative value. What is the value is here? This is the minus 5 is that 24 minus 3 into 5 power k plus 5 is that. Okay. Minus 21 times of 5 power k plus 15 times of 5 power k. What will get here? Minus 21. This is minus 6 times of 5 power k plus 35 minus 5 is plus 30. Okay. Here is 24 is common. 24 is not common at all. Next, how will we do that 24 is not common here? So that I am just rewriting this value. How I just rewrite the value is 24 as it is, 7 power p as it is. Directly 24 is present in the first term. Remaining two terms 24 is not there. Okay. Here I just take the minus 6 is common from these two terms. If I take a minus 6 is common, what happens? 5 power k as it is. This is minus. It is 5. Are you sure? Minus 6 is common. 6 into minus 6 into minus 5. Minus plus 30. I got it. Okay. Now 24 times of 7 into p minus 6 times of 5 power k minus p. Okay, no need to write this one as it is the same thing is that here. Now we get the 24 is common. How to get the 24 is common? Means what is the k value here? K is any positive integer as well. N is a positive integer as well as k is also positive integer. Or n is a natural number, k is also the natural number as your assumption already know. Suppose if I replace in this term 5 power k minus 5 is there. If I keep on replacing the k value 1, 2, 3, so on, what will you get? First term, k value is 1. 5 power what? 5. 5 minus 5, 0. Okay. K value is 2. 5 square, 25. 25 minus 5 is 20. Next, 3. 5 cube. 5 cube is 125. 125 minus 5 is 120. Like that, it continues. This is the values of 5 power k minus 1 after replacing the k values 1, 2, 3, so on. 6 into these term. 6 into these term. What happens? 6 into 0. 6 into 20. That is 120. 6 into 12. That is 720. Okay, like that. Now from these values, is the 24 is common? Check it. 24, how much of 120? Or else I need to take the 24 is common. Okay, 6 into is that. So here, apart from that, or one more way. Once again, are you getting confusion? Just a simple thing is that observe that. Come to the LHS value. We need to prove that P of k plus 1 is true. Okay, P of k plus 1. Wherever n is there, let's just replace the k plus 1. We need to prove that LHS equal to RHS. But it is not there in that manner. Here statement is the. What is the statement? It is divisible by 24. We need to prove that this number is divisible by 24. For that, LHS value is considered. This number is divisible by 24 means it is sufficient to take the 24 is common. Our aim is to get the 24 is common from this number. How I am just taking the 24 is common means I am just splitting the 7 power k plus 1 5 power k plus 1 as in this manner 2 into 7 power k plus 3 into 5 power k plus 1 can be split into 5 into 5 power k minus 5. Now from the equation number 1 replace the 2 into 7 power k value. Replace the 2 into 7 power k value. Simplify. So here after simplification we just got this result. This result we just got 24 times of 7 power k. Out of the 3 terms 24 is common from the first term. But here it is not 24, here also it is not 24. Next. Here I want to take the common as a 24. For that I am just rewriting. Minus 6 is common. This is the minus 6 is common. 5 power k minus 5 is left. Now I am just telling that 5 power k minus 5 after replacing the k value 1, 2, 3, these are value. So these brackets value are multiples of 4. These are all the multiples of 4. Check it. 4, how much are 20? 5 are like that. These are all the multiples of 4. 30s are 120 like that. Multiples of 4 are there. Okay. So these are the multiples of 4 is nothing. But can I write that to 5 power? I just stop this one. Can I write that 5 power k minus 5 is multiples of 4 is nothing but 4 times of some m, where m is the any integer. Where m is the any integer. M is the any positive integer. 5 power k minus 5 is a multiple of 4. Why it is a multiple of 4? I have already explained. Replacing the k value 1, 2, 3, so on, we will get the multiples of 4. Now, replace this value into the upper equation. 24 times of 7 into p minus 6 into 5 power k minus 5 is a multiples of 4. That means 4 times of m. That means 24 into 7 power p minus 24 times of the m. Are you clear? Now, is 24 is common? Yes, 24 is common. What is that? 7p is left minus m is left. So, from this LHS part, simplifying, whenever the 24 is common. Yes, we just got the 24 is common. Now, can I say that the LHS value is divisible by 24. Therefore, P of k plus 1 is 2. Therefore, P of k plus 1 is 2. I got this point. How to solve this problem? Here, this is the thing. I just express multiple of 4 because I need to get the 24 is common. I just extracted the 24 is common term. So 24 is common, which is got it. Required result is multiple of 4 or divisible by 24. Hence, P of k plus 1 is 2. P of k plus 1 is 2 means final conclusion. The given statement P of n is true for all the natural number, which means that 2 into 7 power n plus 3 into 5 power n minus 5 is divisible by 24 for all the natural number. Are you sure? Okay, just practice this problem. The same type of the problem will continue in the next video. Now I just stop here. The remaining problems of this type of problem will continue in the next video. Okay, thank you.